Hello children, this video is part 6 of chapter 1 Chemical Reactions and Equations class 10. Children, balancing of chemical equation isn't difficult once you have proper knowledge of the symbols, valencies, formulas and equations correctly. And then just by following certain steps, as we have already discussed in our previous video of part 5, except the two secrets which I am going to reveal in this video, which will make the balancing a real super easy one. We can master the balancing skills just by practice and more practice. So let's balance the following skeletal equation. Number 1, magnesium nitride reacts with water to produce magnesium hydroxide and ammonia gas, as do many metal nitrides. So the word equation for this is written as magnesium nitride reacts with water. So magnesium nitride plus water produce magnesium hydroxide and ammonia gas. So here it gives magnesium hydroxide and ammonia. Now this is the word equation for this chemical reaction. We will convert this word equation into the chemical equation. So the magnesium nitride is written as Mg3N2. Here you must have the proper knowledge of the symbols and valencies. So the valencies of magnesium is 2 and the valency of nitrogen is 3. This you have already studied in class 9. Now this magnesium nitride reacts with water. So the symbol of water is H2O. Valency of hydrogen is 1 and that of oxygen is 2. It reacts to give magnesium hydroxide. So magnesium with valency 2 and hydroxide has a valency of 1. Ammonia, valency of nitrogen is 3 and valency of hydrogen is 1. So now let's start balancing this chemical equation. As I have already explained, two ways of balancing the chemical equation. One is by hit and trial method and another one is by ABCD method or algebraic method. So we will be balancing this chemical equation by both the methods. So first let us balance by hit and trial method. And you know that in this hit and trial method as given in your NCERT, we have to follow certain steps. So let us see. First we will draw the boxes around each formulas. And why? So that we do not alter the formula of the compound while balancing. And then we will find out the number of atoms of each element and we will start balancing the equation with the element or compound having maximum number of atoms. So let's first draw the boxes around the formulas so that we do not alter the formula while balancing. Next we will start balancing with the element having maximum number of atoms, except the secret is that leave the oxygen and hydrogen to be balanced in the last. So we will begin by balancing magnesium. So here you have 3 atoms of magnesium and this side you have 1 atom of magnesium. So to make this magnesium, we will multiply it by the coefficient 3. So now let us check the whole equation on both the sides. So here on the reactant side you have 3 times 1 magnesium and here on the product side you have 1 times 3 magnesium. So magnesium has got balanced on both the sides. Now let us move on to another element. So let us talk about nitrogen, because the secret of balancing any chemical equation easily is that you leave the hydrogen and oxygen to be balanced in the last. So when we look at this nitrogen, you have 2 atoms of nitrogen. So we will balance on the product side by placing 2 in front of ammonia. Now again check the whole step. So 3 times magnesium, 3 times magnesium. Magnesium has got balanced. For nitrogen, 2 times nitrogen. And here on the product side you have 2 times nitrogen. So nitrogen is also balanced. Now let us see what changes have occurred for the oxygen and hydrogen. So here first we will talk about hydrogen. So on the left hand side, that is on the reactant side, you have 2 atoms of hydrogen and on the product side, that is on the right hand side, you have 2 times 3, that is 6 hydrogen plus 3 times 2, that is 6 hydrogen again. So in total you have 12 hydrogen atoms on the product side. So let us balance this hydrogen atom. So while balancing, you have 12 hydrogen atom on the product side. So to make this hydrogen 12, what we will do? We will multiply this 2 hydrogen atom with which number? Yes, by 6. So 2 times 6 makes 12. So here now on the reactant side you have 12 hydrogen atom, and on the product side also you have got 12 hydrogen atom. It means that hydrogen has got balanced. Now again the same, we will be rechecking the whole equation every time whenever we make any changes. So let us see. So here on the reactant side you have 3 magnesium atom, on the product side also 3 magnesium atoms. So magnesium has got balanced. Then for nitrogen, on the reactant side you have 2 nitrogen atom, and on the product side also you have 2 nitrogen atoms. So nitrogen has also got balanced. So now let us check the hydrogen atom. So on the reactant side you have 12 hydrogen atoms. 6 times 2 is 12. And on the product side you have 2 times 3, that is 6, plus 3 times 2, that is 6. So altogether you have 12 hydrogen atoms on the product side. So hydrogen has also got balanced. Now let us see if there is anything which is left unbalanced. Yes, we have oxygen which still needs to be balanced. So here you have 1 times 6. So 6 oxygen atoms on the reactant side, and on the product side you have 2 times 3, that is 6 oxygen atoms on the product side. Yes, so here we see that the oxygen has automatically got balanced just by following the secret of leaving the hydrogen and oxygen to be balanced in the last, and start balancing the elements which has maximum number of atoms on either of the side. That is why we began from magnesium. We did not touch the hydrogen and oxygen. Then again we balanced nitrogen. So just by following the secret, we have balanced this chemical equation by hit and trial method so easily. So as I said, master this balancing skill just by practice, practice and more practice. Now let us balance the same chemical equation with the second method, that is algebraic method, which you also call it as ABCD method. So first let me write down this chemical equation for you. So it is magnesium nitride Mg3N2 plus water H2O gives magnesium hydroxide MgOH2 plus ammonia NH3. Children, observe that while writing the formulas, I have left a sufficient gap before the formulas so that I have enough space while writing the coefficients. So now let us begin. I'll write down the alphabet A, B, C and D in front of all the formulas. That is the first step. The second step is we will write down all the elements which is present in the reaction. So here you have magnesium, nitrogen, hydrogen and oxygen. Now following the law of conservation of mass, let us see how many magnesium element is present on both the sides. So it is 3 times A, that is 3A is equal to 1 times C, that is we do not write 1, so it is 3A is equal to C for magnesium. Then let us check for this nitrogen. So it is 2A is equal to 1D. So 2A is equal to 1D. So we will be writing 2A is equal to D. Then move on to next element, that is hydrogen. So hydrogen on the reactant side is 2B is equal to, on the product side you have 2C plus 3D. Now for oxygen, On the reactant side you have 1B. So you have B is equal to, for this oxygen which is inside the bracket, so you have 2C on the product side. Now the next step, what we will do? Yes, we will assume any of the alphabet which is repeated maximum times to be 1. So let us see, you have A, 1, 2, yes, so A is 2 times. Then C, 1, 2, 3. So C you have 3 times. Then D, 1, 2. So D is 2 times and B, 1, 2. So B is 2 times. So here we are noticing that you have C maximum times. So we will assume C to be 1. So let C be 1. As soon as we have assumed C to be 1, so what will be the effect on other? So here by placing 1, you will get the value of A. So 3A is equal to C. It means 3A is equal to 1. Therefore, A is equal to 1 by 3. So now you have got the value of A to be 1 by 3. Yes, we will find out the value of D. So putting this value of A as 1 by 3 here. So D is equal to 2 times A. And from here we have taken out the value of A to be 1 by 3. So 2 into 1 by 3. Therefore D is equal to 2 by 3. So now you have got the value of D as 2 by 3. Now let us find out the value of B. So you have B is equal to 2C and we know that C is 1. So we have B is equal to 2. So here you have got the value of B as 2. Now put all these values in the main chemical equation. So for A you have 1 by 3 magnesium nitride, plus for water you have 2 as a coefficient. So 2 for water gives, for C it is 1, and we know that we do not write 1 as a coefficient. So magnesium hydroxide is MgOH2 and here we assume to be 1, plus D. So this D you have 2 by 3. So for ammonia it is 2 by 3 ammonia gas, that is NH3. Now when we observe this chemical equation, we are seeing fractions here on the reactant and product side. So we will convert it into the whole number by removing the denominator. So now what we will do to remove this denominator? 3. Yes, we will multiply the whole equation by 3. So now the final equation will be, so this 3 on the denominator side and this 3 on the numerator side will get cancelled. So we will have Mg3N2 plus 3 times 2. So 6 water gives 3 times 1. So 3 magnesium hydroxide plus 2 upon 3 multiplied by 3. So this 3 in the numerator and denominator will get cancelled. So it will be 2 ammonia. Now the final step, we will write down the physical state of these compounds. So magnesium nitride is solid in state, water is liquid in state, magnesium hydroxide is aqueous in state, plus NH3, that is ammonia, is gaseous in state. So now this is a balanced chemical equation by algebraic balancing method. Let us check the same we have got with the hit and trial method. So this is a balanced chemical equation by hit and trial method and by algebraic balancing method. I hope this is clear to you. Now let us practice some more chemical equation. Children, now let us balance another chemical equation, that is decomposition of lead nitrate on heating. Now what is this decomposition will be explained in my upcoming series on types of chemical reactions. Here for the time being, just understand that decomposition means to break down. So here this lead nitrate decomposes on heating into lead oxide, nitrogen dioxide and oxygen. This heating is denoted by a capital Greek letter delta. So, if the reaction requires energy in the form of heat, so this capital Greek letter delta is written on top of the reaction arrow so that the energy in the form of heat is added to the reaction. So we can read this chemical equation as lead nitrate on decomposition yields lead oxide, nitrogen dioxide, and oxygen. Let us balance this chemical equation first by hit and trial method. Children, by now we have ample of practice in balancing the chemical equation, so we will skip the step of placing all the compounds or the element inside a box. We will also skip the step of listing the number of atoms present in each elements on both the sides. Now directly move on to the third step. The third step says that start balancing the element which has maximum number of atoms, and it can be on any of the sides. So when we observe this chemical equation, it is seen that we have lead one atom on the reactant side, that is on the left hand side, and one atom of lead on the right hand side as well. Then we have two atoms of nitrogen on the reactant side and one nitrogen atom on the product side. For oxygen, we have 6 atoms of oxygen on the reactant side and 1 plus 2 plus 2. That is 5 atoms of oxygen on the product side. But we know the secret tip that it's a good strategy to always leave oxygen and hydrogen to be balanced till last. Here in this chemical equation we have oxygen, so leave oxygen to be balanced till last. Then we will first talk about lead and nitrogen, and according to this chemical equation, as per the step, we should start balancing with the element which has maximum number of atoms, and it can be on either of the sides. So when we observe this chemical equation, we have one atom of lead on the reactant side and one atom of lead on the product side. Then for this nitrogen, we have two nitrogen atom on the reactant side and one nitrogen atom on the product side. And as we know that it is a good strategy to leave oxygen and hydrogen atom to be balanced till last. So as per this chemical equation, the maximum number of atom is for nitrogen, and it is 2 nitrogen atom on the reactant side and 1 nitrogen atom on the product side. So in order to balance this nitrogen atom, what we will do? Yes, on the product side, we will multiply this nitrogen by 2 so that we have 2 nitrogen atoms on the product side. Now, recall the basic step that whenever you make any changes on any of the sides of the chemical equation, you will have to recheck both the sides every time. So, we have 2 nitrogen atoms on the reactant side and 2 nitrogen atom on the product side. 1 lead atom on the reactant side, 1 lead atom on the product side. Now, as we are leaving oxygen to be balanced till last, so the next we are going to balance is this lead. So, on observing this, it is 1 lead atom on the reactant side and 1 lead atom on the product side. So, this lead is already balanced in this chemical equation. Now, as we are left with oxygen atom, so let us see how many oxygen atoms do we have on the reactant side. Yes, this is 2 times 3, that is 6 oxygen atom on the reactant side, and on the product side we have 1 plus 2 times 2, that is 4, plus 2 times 1, that is 2. So on the product side we have 1 plus 2 times 2, that is 4, plus 2 times 1, that is 2. So we have 1 plus 4 plus 2, that is 7 oxygen atom on the product side. Now, on observing this, it is seen that we have odd number of oxygen on the product side. Now, this is a bit challenging equation. So, in order to balance this oxygen atom, if we multiply this oxygen atom by half, so this 2 and this 2 will get cancelled and we will have one oxygen atom. So children, remember that we can use even fractions in order to balance the chemical equation. Fractions can be used as coefficient. It is not wrong. It can be done. But we know that half molecule of oxygen is not possible. So what we will do, we will multiply both sides of this whole chemical equation by 2, so that the 2 on the denominator and the 2 on the numerator, when gets cancelled, it will be one molecule of oxygen atom. So when we multiply the whole equation by 2, we get 2 PbNO3 whole twice upon heating gives 2 PbO plus 2 times 2, that is 4 NO2 plus this 2 on the denominator and this 2 on the numerator will get cancelled. So we will get one molecule of oxygen atom. So it is 1O2. And we know that we don't write the coefficient 1. We assume that 1 is present here. Now back to the basic step. That is, whenever you make any changes on any of the sides of the chemical equation, we have to always recheck both the sides. So on rechecking, it is observed that we have 2 atoms of lead on the reactant side and 2 atoms of lead on the product side. And for this nitrogen, we have 2 times 2, that is 4 nitrogen atom on the reactant, and 1 times 4, that is 4 nitrogen atom on the product side. And for this oxygen, we have 3 times 2 times 2. So in total, we have 3 2s are 6, 6 2s are 12. So 12 oxygen on the reactant side, and on the product side we have 2 plus 2 times 4, that is 8, plus 2 times 1, that is 2. So 2 plus 8 plus 2, this is 12. So on the product side also we have 12 oxygen atoms. So this way the chemical equation has got balanced by hit and trial method. So here we have also learnt, and another secret tip is that fraction can be used as coefficients but converted to whole number finally. That is why we have multiplied this whole chemical equation by 2. So this is how we have balanced the chemical equation by hit and trial method. Now let us balance the same chemical equation by another method, that is algebraic balancing method. So let me write down this same chemical equation for you first. So the chemical equation is PbNO3 whole twice upon heating gives PbO plus NO2 plus O2. So for this algebraic balancing method, we write down the alphabets sequentially for each of the compounds and elements. So it is A PbNO3 whole twice upon heating gives B PbO plus C NO2 plus D O2. Now for this algebraic balancing method, we have learnt that you write down all the elements separately which is in the reactant. Lead, that is Pb, then we have nitrogen and we have oxygen. See, on the product side also it is the same, lead, then nitrogen and oxygen. Now as per the law of conservation of mass, we will equate both the sides of each of the elements. So for this lead we have 1 times A in the reactant side is equal to 1 times B on the product side. Then move on to another element. It is nitrogen here. So we have 2 times A, that is 2A is equal to 1 times C. So it is 2A is equal to C. Now move on to oxygen. For this oxygen atom we have 3 times 2, that is 6A is equal to 1 times B plus 2 times C plus 2 times D. Now the next step, we will assume any of the alphabet which is repeated maximum time to be 1. So we have A as 1, 2 and 3. So we have A 3 times. Check for B. So B is 1, 2. So B is 2 times. Then check for C. So we have 1, 2. 2 times C. Check for D. We have D only once. So it is observed that A is repeated 3 times. So let A to be 1. Now children, here I need to mention is that if any of the alphabet which is repeated the same times, what I mean to say is that suppose A is present 2 times, B is also present 2 times, even C is also present 2 times, and D is 1 time, then what we will do is that we can assume any of A or B or C to be 1. Here A is present 3 times, so I am assuming A to be 1. Now put this value of A here in order to get the value of B, and we know that A is 1, so automatically B will also be 1. Now put the value of this A here also in order to get the value of C. 2A is equal to C. On putting the value of A to be 1, we get the value of C, which is 2 times 1, that is 2. So we have the value of C as 2. Now we are left with D. In order to get the value of D, we will write down the values of A, B and C in this equation. So it is 6 times A. A is 1 is equal to B. For this B, put the value of B as 1 plus, for this C, put the value of C as 2 plus, we have to find out the value of D. So plus 2D. So this is 6 is equal to 1 plus 4 plus 2D. Now this is simple mathematical equation. 6 is equal to 1 plus 4 is 5 plus 2D. 6 minus 5 is equal to 2D. 2D is equal to 1. Therefore, D is equal to 1 by 2. This way we have got all the values of the alphabets. So on putting the value of these alphabets in the main equation, we have A as 1. So the equation is 1 PbNO3 whole twice upon heating gives BPBO, and B is 1. So 1 PBO plus CNO2. On putting the value of C as 2 NO2 plus, for this D we have half O2. On observing this chemical equation, a fraction is seen. So in order to remove this fraction, what we will do? Yes, we will multiply this whole chemical equation by 2 so that this numerator and this denominator gets cancelled and we get the whole number. So our final equation will become 2PbNO3 whole twice upon heating gives 2PbO plus 2 times 2, that is 4NO2 plus this denominator 2 and the numerator 2 when gets cancelled we get 1O2. Now this is the balanced chemical equation. We have 2 lead on the reactant side and 2 lead on the product side. Then we have 2 times 2, that is 4 nitrogen atom on the reactant side and 1 times 4, that is 4 nitrogen atom on the product side. And 3 times 2, that is 6 times 2, that is 12. So 12 oxygen atom on the reactant side and 2 plus 2 times 4, that is 8 plus 2 times 1, that is 2. So we have 2 plus 8 plus 2. It is 12. Thus we see the chemical equation has got balanced by the algebraic balancing method. Now our final step is write down the physical states of each element. So we have lead nitrate, which is solid in state, lead oxide again solid in state, NO2 is gaseous in state and oxygen is also gaseous in state. And this is the balanced chemical equation by algebraic balancing method. It is the same as we have by hit and trial method. Children, I hope it is clear to you. Now let us move on to another chemical equation and see how it gets balanced. Now let us consider another chemical reaction and try to balance it out. After all, practice makes perfect, isn't it? So here, sodium phosphate on reaction with potassium hydroxide yields sodium hydroxide and potassium phosphate. Now here the secret tip is, if the same polyatomic ion exists together on both sides, keep it together while balancing. Now what is this polyatomic ion? Poly means many and atomic means atoms. So polyatomic ion is an ion that contains more than one atom. This you have already studied in class 9 chapter 3, Atom and Molecules of NCERT book. So some of the common polyatomic ions are phosphate, sulfate, hydroxide, carbonate, etc. So when we observe this chemical reaction, let us list down the number of elements on the left hand side and on the right hand side. So number of sodium atoms on the left hand side we have 3 and on the right hand side we have 1. This PO4 is polyatomic phosphate ion, so we will keep it together. Thus we see that we have 1 atom of phosphate ion and on the reactant side also we have 1 atom of phosphate ion. Then for the next element potassium, we have 1 atom of potassium on the reactant side and 3 times 1, that is 3 atoms of potassium on the product side. Then for this polyatomic hydroxide ion OH, we will put it together. So we have 1 hydroxide on the reactant side and 1 hydroxide on the product side as well. Now let us balance it. We know that to balance the chemical equation, we should start with the element that contains maximum number of atoms. So on observation, it is seen 3 sodium atom on the reactant side. So in order to balance it on the product side, we need to multiply it by 3. So we have 3 sodium atom on the product side. Now the basic step, whenever we make any changes on any of the sides, we have to recheck both the sides. So we have 3 sodium atom on the reactant side and 3 sodium atom on the product side. So sodium is balanced. But now the hydroxide ion has got changed. It has become 3 on the product side. So in order to balance it, we need to multiply this hydroxide ion by 3. So when we multiply this hydroxide ion by 3 on the reactant side, it will be 3 KOH. Now again back to the basic step, that is we need to recheck both the sides. So we have 3 sodium atom on the reactant side, 3 sodium atom on the product side. So sodium is balanced. Then we have 1 phosphate on the reactant side and 1 phosphate on the product side. So phosphate is balanced. We have 3 hydroxide ion on the reactant side and 3 hydroxide ion on the product side. So hydroxide ion is balanced. But now the potassium has got changed. Now it has become 3 on the reactant side. Recheck both the sides. On rechecking, we find it is 3 sodium atom on the reactant side and 3 sodium atom on the product side. So this sodium is balanced on both the sides. Then for this phosphate, we have 1 phosphate on the reactant side and 1 phosphate on the product side. So this phosphate is also balanced. For this potassium atom, we have 3 potassium atom on the reactant side and yes, 3 potassium atom on the product side as well. So this potassium is also balanced. Then for this hydroxide ion, we have 3 hydroxide ion on the reactant side and 3 hydroxide ion on the product side. So this hydroxide ion is also balanced on both the sides. This way the equation has got balanced by hit and trial method. Thus we have learnt one more secret step, that is, if the same polyatomic ion exists together on both the sides, then we should keep it together while balancing. Now let us solve the same one with the second method that we have learnt, that is algebraic balancing method. So let me write down this chemical equation for you. It is Na3PO4 sodium phosphate plus potassium hydroxide KOH on a reaction gives sodium hydroxide NaOH plus potassium phosphate K3PO4. Now for this algebraic balancing method, what we do? We assume the coefficients to be alphabet A, B, C and D. After that, the next step is we will write down all the elements present in the reaction separately. So we have sodium, phosphorus, then we have oxygen, then potassium, and we are left with hydrogen. So these are the elements present in this chemical reaction. Now move on to the next step, that is sodium is 3 times A on the reactant side is equal to 1 times C on the product side. So 3 is equal to C. Then move on to the next element, that is phosphorus. So we have A is equal to D for phosphorus. Then for oxygen we have 4 times A, but there is one more oxygen. So here plus 1 times B, that is B is equal to 1 times C plus 4D for oxygen atom. Now move on to the next element, that is potassium. So we have 1B, so B is equal to 3D. And finally for hydrogen we have B is equal to 1 times C is C, and that's it. Now the next step, let us assume any of the alphabet which is repeated more times to be 1. So here let us see how many A's do we have. So it is 1, 2, 3, 3 times. Then for C we have C is 1, 2, 3. So C is also 3 times. Then check for D. So D we have 1, 2, 3. So D is also 3 times. Then check for B. So B is 1, 2 and 3. Children, here we see all the 4 alphabets are repeated the same number of times. So what we will do now? No worries. We will assume any of the alphabets to be 1. Let C is equal to 1. Then from here B will automatically become 1. So now we have got the value of C and B. Now to get the value of A, what we will do? We will put the value of C here. So 3A is equal to 1. Therefore A is equal to 1 by 3. Now we are left with D. So to get the value of D, what we will do? Yes, we will put down the value of B, which we have already taken out to be 1. So 3D is equal to 1. Therefore D is equal to 1 by 3. So now we have got all the values of the alphabets, that is A, B, C and D. Now substitute these alphabets. We get A, Na3PO4 and A is 1 by 3. So 1 by 3 Na3PO4 plus B is 1. So KOH gives CNaOH, and we know that C is 1. So it is 1 NaOH plus DK3PO4. So D is taken out to be 1 upon 3. So it is 1 by 3 K3PO4. Now, we don't like having fractions in the equation because the number of molecules cannot be in fractions. So, in order to make the chemical equation to be in a whole number, we need to multiply the whole equation by which number? Yes, by 3. Why? Because in the denominator you have 3. So on the numerator, if you will multiply the whole equation by 3, these 3 will get cancelled and the final equation will be Na3PO4 plus 3 times KOH gives 3 times NaOH. So it is 3 NaOH plus, and now this 3 in the denominator and 3 in the numerator will get cancelled and we are left with K3PO4. So this is a balanced chemical equation by algebraic balancing method, and this chemical equation is the same as what we have got by hit and trial method. I hope you have understood how to balance the chemical equation by both hit and trial method and by algebraic balancing method. Now we will practice one more chemical equation and let us see how it will get balanced. This is when potassium hydroxide reacts with carbon dioxide, it yields potassium carbonate and water. Now this is a bit challenging because we have oxygen in all the compounds here. So we have to be little bit more careful when we are adding up the number of oxygen. And yes, one more thing. Here this hydroxide OH is polyatomic ion on the reactant side, but on the product side we don't have hydroxide as the polyatomic ion. And another thing, we have carbonate ion in the product side as the polyatomic ion, but we don't have any carbonate ion in the reactant side. So here the secret tip that we have learnt about the polyatomic ion will not be applied here because this ion is not existing on both the sides. So while balancing this chemical equation, we will consider each elements individually on both the sides. Let us see how. So on observing this chemical equation, the elements present on the left hand side and those present on the right hand side of this arrow when listed down is, we have potassium, 1 atom on the reactant side and 2 atoms on the product side. But yes, here the secret tip, that if in any of the chemical equation you have oxygen and hydrogen, then balance these at the last. Now for oxygen, we have 1 plus 2, that is 3 oxygen atom on the reactant side and 3 times 1 plus 1. So we have 4 oxygen atoms on the product side. Next, for another element, hydrogen, it is 1 hydrogen atom on the reactant side and 2 times 1, that is 2 hydrogen atom on the product side. And for this carbon element, we have 1 carbon atom on the reactant side and 1 carbon atom on the product side. Now in order to balance this, we will follow the step which says that balancing should be started with the element which has maximum number of atoms on any of the sides. So when we observe this, it is seen that we have 1 atom of potassium on the reactant side and 2 atoms of potassium on the product side. Then we have 3 atoms of oxygen on the reactant side, 4 atoms of oxygen on the product side. Then 1 hydrogen atom on the reactant side and 2 hydrogen atom on the product side. And lastly, 1 carbon atom on the reactant side and 1 carbon atom on the product side. Now here we know the secret tip, that if oxygen and hydrogen is present in any of the chemical reaction, while balancing the chemical equation, the oxygen and hydrogen should be left till last. So now when you leave this oxygen and hydrogen to be balanced till last, it is observed that we have maximum number of potassium atom on the product side, that is 2. We need to multiply potassium by which number? Yes, by 2 in order to balance the potassium. So we will write 2 as a coefficient in the reactant side. Now the basic step, that is, whenever we make any changes on any of the sides, we need to recheck both the sides every time. So on rechecking, it is seen that we have 2 atoms of potassium on the reactant side and 2 atoms of potassium on the product side. So this potassium is balanced. So now the number of oxygen has got changed. It has become 2 atoms of oxygen. So it is not 1. Now it has changed to 2 plus 2, which is equal to 4. 2 potassium atom on the reactant side and 2 potassium atom on the product side. Then for this oxygen, we have 2 oxygen plus 2 oxygen, that is 4 oxygen atom on the reactant side, and here we have 3 oxygen atom plus 1 oxygen atom, that is 4 oxygen atom on the product side. So yes, this oxygen is also balanced on both the sides. Now let us check for hydrogen atom. We have 2 hydrogen atom on the reactant side. So now it is not 1. The hydrogen has been changed to 2 hydrogen atom on the. So again follow the same basic step of rechecking both the sides. So on rechecking, it is seen we have 2 potassium atom on the reactant side and 2 potassium atom on the product side. So potassium is balanced. Then for this oxygen, we have 2 oxygen atom plus 2 oxygen atom, that is in total we have 4 oxygen atom on the reactant side and 3 oxygen atom plus 1 oxygen atom, that is 4 oxygen atom on the product side. Then for this hydrogen, let us see what changes has been made. So this hydrogen atom is 2 on the reactant side, and yes, it is 2 on the product side as well. So this hydrogen atom is also balanced. Now lastly we are left with carbon atom. So this carbon atom is 1 on the reactant side and this carbon atom is also 1 on the product side as well. Thus we see that this carbon is also balanced. So children, I hope you have understood how to balance the chemical equation by following the steps that I have dealt in this video and also the secret tips that we have come across. So this way of balancing which we did is by hit and trial method. Now we will be balancing the same chemical equation with the algebraic balancing method. So let me write the equation for you. So it is KOH, that is potassium hydroxide, on a reaction with carbon dioxide gas yields potassium carbonate plus water. So now keep following the steps that we have learnt. The first is we will write down the alphabets as a coefficient in front of each compounds. So here A, B, C, D are the coefficients. Now after writing the coefficient, the next step is we need to write down all the elements present in the compound separately. So it is potassium K, oxygen O, then we have hydrogen H, and we have carbon C. So we have these 4 elements present in this chemical equation. Now the next step is write down the number of atoms that we have for potassium. So it is 1 times A, that is A is equal to 2 times C. So A is equal to 2C for this potassium element. Now for this oxygen element we have 1 times A plus 2 times B on the reactant side is equal to 3 times C plus 1 times D. Now for this hydrogen element we have 1 times A is equal to 2 times D, and for this carbon we have 1 times B is equal to 1 times C. So B is equal to C. Now the next step, we will assume any of the alphabet which is repeated several times to be 1. So here let us see which alphabet is repeated more times. So first we will check for A. So A is 1, 2, 3. So A is repeated 3 times. Let us check for C. So C is 1, 2 and 3. So C is also 3. Then for B we have 1, 2. So B is written 2 times. And for D we have 1, 2. So D is also written 2 times. So now what we will do, since A and C are repeated 3 times, so we can take any of them to be 1. So for simplicity, I will assume A to be 1. Now put this value of A in this equation in order to get the value of C. So on putting the value of A here in this equation, we have 1 is equal to 2C. Therefore C is equal to half. So we have got the value of C as half and we have got the value of A as 1. Now if we put the value of A here in this equation, we can get the value of D. So if I put the value of A as 1, so 1 is equal to 2D. Therefore D is equal to half. Now we are left to find the value of B. Here B is equal to C, but we know that C is equal to half. Therefore on substituting the value of C as half, we will get the value of B also as half. This way we have got the value of B as half, A as 1, C as half and D also as half. Now on substituting the values here in the main equation, we see it is A KOH and here we have A as 1. So we have 1 KOH plus B CO2 and we have the value of B as half. So the value is half CO2 gives C K2CO3 and we know that the value of C is half. So we have half K2CO3 plus DH2O. We have the value of D as half. So the equation is half H2O. Now, leaving the chemical equation in fraction is a bad idea. So what we will do? Yes, the same step. We will multiply both the sides of the chemical equation by such a number so that the denominator in the fraction gets cancelled. So if we multiply it by 2 as the numerator, let us observe the differences. So here for this KOH, this is 2 KOH plus half CO2. This denominator 2 and the numerator 2 will get cancelled and we are left with single CO2 gives, for this half K2CO3 we need to remove this denominator in the fraction. So if we multiply it by 2, the denominator and the numerator gets cancelled and we are left with 1 K2CO3 plus, again here it is half H2O. So this 2 in the denominator and 2 on the numerator side will get cancelled. So we will have 1 H2O. So now this is the balanced chemical equation and this is the same as the one that we have got with the hit and trial method. So the balanced chemical equation here is 2 KOH plus CO2 gives K2CO3 plus H2O. This is the balanced chemical equation by algebraic balancing method and it is the same as that with the hit and trial method, that is 2 KOH plus CO2 on a reaction yields K2CO3 plus water. And now the final step is we need to mention the physical state of each of the compounds present in this reaction. So here KOH is aqueous in state plus carbon dioxide is gaseous in state gives K2CO3, again aqueous in state, along with the liquid water. Now this is how we have balanced this chemical equation by both the methods. I hope this is clear to you. So children, keep practicing more and more chemical equations in order to develop the balancing skill. Yes, after all, practice makes perfect, isn't it? So see you in my another video where I will be teaching you the different types of chemical reactions given in our NCERT. Till then, keep learning, keep growing. This is Anupama Man signing off.